Hey everyone, welcome back. In the last video, we showed how to create these kinds of tests. So there's a sphere test just to see if I'm within range of this agent. So here this one's green because I am within range, and then these other ones are not. They're all red. So this doesn't give us what we want, right? If I go back into this, he can't see me, right? He's not facing me, so he shouldn't be able to detect me at all. Whereas if I get out here, he should be able to because he can see me. So that's the next thing we're going to look at. So the rest of this, I think, is going to be relatively straightforward. What I want to do is once we have the sphere test, I'm going to do a branch here. And based on this sphere test, and if this fails, then basically we want to clear the target. So false, we're going to do set blackboard, here we go, blackboard value as object. And then we need a key, and of course we have to do this whole thing. So let's do, where are you? Promote to variable. And so this variable, we'll create a whole section called Blackboard keys. And so this Blackboard key, we're going to name target target object. What did I name this thing? In the actual Blackboard itself, I named it target actor. So we'll do the same thing. We'll say target actor key. So that's it. And value we leave as this select asset. This essentially sets it to null. So that's what this does. In fact, I'm going to say not in the hull, perception hull, because that sounds very fancy. Not in the perception hull. So clear the target. So oh no, I guess if I save, oh that's lame. Not in the perception hull, so clear target. Don't hit Control S before you've saved this, or it will break it. Okay, so back out here, if we do have something right over on this side, now what we need to do is we need to check every single object that is within there. We don't strictly have to do this because we only have the player, but I'm trying to kind of future-proof this a little bit, where we might want robots and all sorts of other things. So for now, I'm going to say for each loop with break, I think is what I want. So here's my for each loop. We're going to iterate over reroute. We're going to iterate over this array. Let's do like that. And does have a break. Potentially, it may not actually have a break. So it's going to iterate over all of these hits. Now in here, there's a thing where I can break. Yeah, oh, that was it. Break hit result. So the hit result is like a gigantic struct, and it has all this data. We care about one thing right now, which is what actor did we hit? That's really all we care about. So in this loop, I want to do a visibility test. So that's going to be here, right in this, this is going to be a visibility test. If that succeeds, we can look at a noise test or whatever we want. So let's do the visibility test. And I'm going to kind of crank through this because the visibility test is not that different than the sphere test. It's just a different thing that we're calling, but a lot of the same code is going to exist. So let's see. Visibility test. Oh, I'm here. Inputs. So we're going to need the hit actor, the actor that we just hit. So that's going to be, here, let's search for it. It's going to be an actor. Pretty sure this is an actor. And then we're going to need probably, and then I think all we need is just a Boolean. That should be fine, which is basically success. Did we actually see this thing? So that's what we've got here. Okay, so let's do the actual thing. So what I want to do now is I want to say the magic that we want is line trace by channel. That's what I want to do. So this line trace by channel is essentially a raycast. It's going to try and draw a line between two things. All right. So we want get actor location. Oh no. Here, let's do it like this. Get actor location. And so this is our location right here. We want our agent location as well. So that actually means that we're going to need another parameter. And I kind of want to put this above this for whatever reason. And I'm going to say the agent. We're probably going to pass this into most of our functions. This is going to be our pawn. Where are you? There you are. So we'll need this guy as well. And this is also going to be get actor. Where are you? Location. There it is. So we have our agent as the start point, the actor that we hit as our end point. So that's what we've got. We're ignoring objects. So we want to ignore these guys. We want to use our debug draw type. This is why we've made these tuning values. So if we're drawing the sphere, we might as well draw this stuff too. We're ignoring self and all this other stuff. Trace channels are they're counterintuitive. You know, we're going to use camera for what it's worth. But, you know, you can read up on them. They're a little counterintuitive. Very briefly, if I open this guy, deep in here somewhere, we're going to have some of our, like, collision stuff. And we have all this. This isn't it. Somewhere in one of these guys, we're going to have our, like, oh, wait, collision presets. This is it. So we have our trace responses. Visibility is ignore, whereas camera is block. So that's why we want camera. Camera is sort of visibility, where I actually don't know the purpose behind this, except that you have two channels that you can edit and change. We want camera because camera essentially is visibility. So again, camera says we are going to, like, this object blocks the camera. Trees and so on will block camera trace responses. So we want camera trace responses. That's what we're looking for, because we want world objects and stuff to block it. That's why we're choosing camera. It's sort of an unfortunate name. Okay, so that's what we've got there. We can kill this. Here, I'll just kill this and move him over there. So this is our actual raycast. So perform raycast. Now what we want to do, here, I'll actually name this something a little better. Raycast to target. Now, so if we fail our raycast, then we return failure. If we succeed our raycast, then obviously we succeed. So we're going to do the same thing here. We're going to say, so if this, I'll pull this guy down here. If this fails, we actually want this return node. If this fails, we're going to return failure, basically. Here, we're going to break this guy out. Again, we have hit actor and all this other kind of stuff. So what we want to do now is we want to say, hey, if the actor that we hit is this hit actor that we have, I can kind of pull this guy over here. Where's my reroute? There it is. There's a hotkey for this that I forget. Maybe it's something. Maybe it's Alt. That wasn't it. Oh well. Someone can leave a comment for me as to what it is. Let's see. Add reroute. And so on. So we're going to basically pull this guy over, and we're going to say, hey, is the actor that we hit the same actor that we're looking at right now? Are these guys the same? You know, and actually I'm going to reverse this logic a little bit. I'm basically always gonna break this. This feels better. And then I'll pull this guy kind of down here. I'll pull these guys out so I can say hit actor, and then this guy. So the reason I'm doing this is because I basically want this or this sort of return value that's back here. Yeah. This will be null anyway, so this should be okay. Okay, so then, so here's where I'm going to put the if statement. This feels better. This guy comes up here, basically. We'll kind of move this guy out of the way a little bit to clean up. And then this return node can go here. So if this fails, then, you know, sad face and we're done. If this succeeds, so this is just, you know, this is basically, did we hit this actor? That's all this really is. The last thing that we need to do, if this is the actor, we're not done yet, because it's not just enough for me to be, like, for him to be able to hit me with a line test. What he needs to be able to do is we need to check to see if he's facing me. This is a little unfortunate because now we're back into math. I hate doing math in Blueprint because it's not great to do node-based stuff. I'd rather just type, you know, a little bit of code and make it work. So let's do the math briefly. The math is, in fact, I'll do it in another function. This function is going to be called is facing target. And the function is going to take a, I think it's going to take both of the things. So here, I'll zoom this in a little bit. It's going to take in the agent, and it's going to take in the target. And this target is actually going to be an actor, not a pawn, because that's what we're looking at. And it's just going to return true or false. Is facing target. That seems fine. Of course, this has to be a Boolean. And that should be good. Okay, this is basically just math. So what I'm going to do is I'm going to, for the agent itself, I'm going to grab, okay, let's move this guy out of the way. We're going to grab get actor location. We're going to get actor forward. So we've got both of these guys. We're going to get the target's location. And we're going to, so it gets a little wonky here. And I'm not going to go super deep into the math, but what we want is we want to do get unit direction from vector here and here. So this gets us a unit direction. Basically, I'm looking at agent location, target location. Give me a unit direction vector. So what that does, briefly, is I'm here, potential target is here. It's going to get me this vector and normalize it so that its size is 1. So then I can multiply it or whatever I want to do. So why that's important is because this is where it gets crazy. We're going to take the dot product of that. I know, this is getting scary. And we're basically, this is super simple in this sense. We're just going to see if it's greater than 0. And, you know, I could go, like, if you've never seen a dot product before, I would briefly look up some of the math and some of the magic behind it. Basically, if I have a vector facing in a particular direction and I take the dot product of another vector, I can tell, are they facing each other? Are they facing away from each other? And so on, just by looking at some of the values. So I would highly recommend looking at this stuff. As a slight rant, I think one of my biggest issues with designers, especially design students, is a lack of basic trigonometry and basic math. This kind of dot product thing should be mostly second nature, I think. Or at least maybe not second nature, but I don't know, third nature. Like it should be something that you could at least look up and replicate. Because this kind of stuff, I mean, that's how we're telling if you're facing in this direction. I mean, look how common that type of question is. Okay. And then all I'm doing is I'm saying, is this true? So this will look in sort of the forward half. In other words, I have to be, so if I were to go to this guy and draw a perfect line through him, right, like this, if I'm on this side of the line, he'll see me. If I'm behind that line, he will not see me. So that's the idea. Okay, that's it. So now we have our function. Where is it? Find target. We're going to build this guy. I think we're good. Yeah, we're good here. Okay, so back out to our sphere test. Sorry, not sphere test, visibility test. The last thing we want to do is we say, hey, if this is true, then is facing target. So this is facing target. We need to pass in, you know, our dudes here. This hit actor. So I always get super awkward using these things. Add reroute. I mean, I could make it local or something, but that's kind of lame. The software engineer in me cringes at that. But, you know, this is not great. So add reroute. We'll pull this guy over here. And this guy here. So now what this is going to do is it's going to say, are we facing the target? And that's what we want to return. Return node. So now we want to say do a facing test and return the result. Here's our visibility test. That's all. So that's what we got. So what I want to do now is I want to go, where is it? Find target. I want to go back to our event graph. And I want to kind of do this thing that we were supposed to be doing. So that if we get, like, in this loop body here, in this event graph, you know, I said that what we want to do is we want to do this visibility test. Visibility test. And we're going to pass in the actor that we hit here. And then we want to pass in, you know, the controlled pawn as our agent. And we'll do something like that to make it a little better. And here we go. And we have more stuff to do, but I'm just going to do a print. And I'm going to say, let's do it like this. Let's do if true. I'm going to say visible, false, you know, not visible. So this will just do a little test. We'll see it as well, but this is a nice little kind of test. Oh, and you're the condition. Make sure I did all that. Okay. So we're going to build this. We're going to run it. We're going to see what happens. So I'm visible according to this. I'm visible on this side as well. So something broke in my little test. So let's kind of jump back and figure out what's going on. So my visibility test broke. Actors to ignore, draw the thing, traces camera. So it's probably this guy that failed. Pretty sure that this is the thing that ended up having to fail. Okay, let me take a look at this and then I'll see what's going on. Okay, so I wonder if you guys spotted it. I dug through this and I just made a dumb little mistake. So the issue was I just swapped these. I'm getting the location and then passing this forward vector. These actually, I need to get the location. I just swapped these out. Get actor location, which is here, right? Because I need to get the unit vector from the two locations. And then of course this is going to be get actor forward vector. And then this will go here. So that's it. Because we want to get the direction vector and the forward vector that we're doing the dot product over. So, you know, dumb little mistake. Okay, so let's compile this. And so if I go back here and I run it, there we go. Not visible. Still not visible. And if I go here, now we're visible. Now we're not visible. Visible, not visible. Visible, and so on. And I could just like go over here and then notice it's not even printing anymore. And it's not printing because I'm not even in the hull, right? It doesn't matter. There we go. Now you can see me. And if I drop down here, here we go. I'm not visible because he can't see me through the terrain. Now, I could change this. Right now he's coming from basically his root node, which is his like hips. Probably I should raise that. That feels reasonable, right? Raise where the source of this is coming from to his face, because he should be able to see me here and he can't. So that's kind of a bug. All right, let's fix that. That should be a simple enough fix if I go here to the visibility test. And I just kind of pull this guy back a little bit. Pull this guy back a little bit. And I want to do, you know, I could do get actor location plus some value. That's simple enough. So I could say, you know, plus, you know, whatever my head offset is. Maybe it's 10 or something like that. Like this is, so like, okay, so I have to pull you in here. I'm just kind of doing this messily right now. Probably you would tune this or something. Or this would come from the actual model itself. So let's do something like this for now. Let's just see if this makes a difference. Run. Barely. I probably need a much larger number. Let's do 100. 100 should go well. There we go. That's too high. So, you know, you can just, and, you know, I could do this much better than this. Like, I could tune this. This might actually be something I don't even tune on this object. It might be something I tune on the character itself. Seems a lot more reasonable. Let's see what 80 does. Yeah, that feels about right. Could even be a little lower. But now he can see me. Now, I'm still going to get a little bit of an issue. Like right at the edges. Oh, I'm too far. Yeah, like he kind of should be able to see me, but the problem here, of course, is that he is going to my root. So he's going to see my root. But it's better. So here we go. Right now, he's a lot better. And I can kill him. There he goes. Okay, so that's it. That's what I wanted to go over in this video. You know, we've got a couple of things. We still need to get some sound in there. Sound will be pretty straightforward. There's some stuff that I want to do, and I want to create like, you know, levels of noise and that kind of stuff. But for now, this is a good start for just basic perceptions in the game. Okay, that's it. I will catch you next time.